I'm welcome. I'm trying to learn electrical engineering today, ammeters and voltmeters, and after we've done that, we're gonna do a bit standing yoga. And if you participate in the standing yoga, then it's with your own. Ammeters and voltmeters. Later in this series, we will be considering the principles involved in the construction of galvanometers. Okay, we're gonna learn about another apparatus, another instrument later. Measuring instruments which detect and measure the passage of very small electric currents through them. Okay, the galvanometers. Okay, galvanometers are measuring the electric current from the passage through them. So it goes from galvanometer measure the amount of electric current which passes through them. Such instruments are updated so that they can be used to measure large currents, and that is as ammeters, and to measure potential differences, that is as voltmeters. Okay, voltmeters. No, a rheostat. We had in the previous part a rheostat. A rheostat is used to make the resistance more or less. You can say I want 2 resistance, 2 ohms or 6 ohms or 10 ohms. So rheostat makes resistance stronger. And galvanometer is able to measure small electric currents which passes through them, to measure electricity or current. And such instruments are adapted so that they can be used to measure large currents. And that is an ammeter. And an ammeter is the same as a galvanometer, just for bigger measurements. An ammeter is measuring how much electricity runs through it. And to measure potential differences, that is as voltmeters. And the voltmeter is used to measure the potential difference, how much electric current came in and how much current comes out. The way in which this adaptation is made determines how ammeter and voltmeters must be used in circuit. We had set something up, and that says how we have to use our ammeters to measure the strong electricity and our voltmeters to measure how much potential difference will be. Ammeters measure large currents by sampling a small part of a current and allowing the bigger current to pass through a low resistance wire called a shunt. Okay, there's sampling. I don't know what sampling is. I understand it is when we get bigger, or at least of it copying it. Either copying or copying and bigger. Or a small part of a current and allowing the bigger current to pass through a low resistance wire called a shunt. If, for example, the galvanometer shown can only register a maximum current of 15 milliampere, and the circuit current I is to be measured is 2 ampere, so I guess 2000, then 1.085 ampere must flow through the low resistance shunt and only 0.015 ampere through the galvanometer. And I said it broadly, so it's just split it and it's able to measure the one, and now it can guess what the other one is. Let's do it again. Ammeters measure large currents by sampling a small part of a current and allowing the bigger current to pass through a low resistance wire called a shunt. Okay, we're getting a little bit through themselves and the bigger amount to the shunt. If, for example, the galvanometer shown can only register a maximum current of 15 milliampere, and the circuit current to be measured is 2 ampere, then 1.085 ampere must flow through the low resistance shunt and only 0.015 ampere through the galvanometer. Wow, why do we come up to 1.085 and then 1.0? Must it not be? Whatever, in the basic we are splitting it and we are able to measure one of them, so we can guess what the other one is or whatever. The pointer of the meter will of course be arranged to indicate the total current of 2 ampere in this situation. That is the top reading on the scale will be marked 2 ampere. So again, saying 2 ampere, it splits it and we know what goes on. The shunt resistance is part of the ammeter and usually fitted inside the instrument, but some laboratory meters have external shunts, which can be interchanged so that one galvanometer can be used to measure various current ranges conveniently. An ammeter is a low resistance instrument, a consequence of the fact that most of the current flows through a shunt. Does that make sense? You will appreciate that this is desirable and intentional. When an ammeter is inserted into a circuit, it must not sensibly reduce the current flowing through it. It must not sensibly reduce the current flowing which it is required to measure. It must not sensibly reduce the current flowing which it is required. Reduce the current flowing which it must not reduce what is flying from, because it takes us a little bit, I think that's what I want to say. It doesn't have to have a big influence on the current going through it, because it has to measure just a small amount of it. Because the main part is delivered in a walk around, or what it's called. Oh, is it a specific idea of it? So not that we are to make a comparison between the two, but to deliver it through without using it. The lower the resistance of the ammeter, the more nearly will the meter fulfill this requirement. When an ammeter is inserted into a circuit, it must not sensibly reduce the current flowing which it is required to measure. Yes, it has not to enormously reduce the amount of current which goes through it to measure it. Voltmeters. A voltmeter is used to measure the potential difference existing between 2 points A and B. The connection of the voltmeter as shown is in parallel with the existing resistance R. Where's R? Where's R? The connection of the voltmeter as shown is in parallel with the existing. Yes, it's just because in parallel measure back at the beginning and after the potential difference making resistor. If the resistance of the voltmeter were not very high, it would have the effect of reducing the potential difference across A and B. The potential difference it is intended to measure. I get it. However, the resistance of a voltmeter is high enough to make no sensible change in the potential difference being measured. I don't understand this, but if the resistance is high, then it has a big influence. It's one of the other versions, called a multiplier or a bobbin in series with the galvanometer. This is achieved by placing a high resistance, called a multiplier or a bobbin, in series with the galvanometer. This high resistance coil or bobbin is sometimes fitted outside the galvanometer as shown for laboratory use, but the normal practice is for the bobbin to be fitted inside the voltmeter. Use of meters. Whenever you set up a circuit, you must therefore always make sure that an ammeter is connected so that the current you wish to measure flows through the meter, placed in series with other circuit components. A voltmeter is connected in parallel across 2 points, so the potential difference across them can be measured. A neglectable current will only pass through the voltmeter. I don't understand why a neglectable, but if the resistance, because the resistance is high, so it's like water. The resistance is high, so the current is not going into it. It goes the other way around because it's the easier way. It would be an explanation why. I don't know if that's the case. If the meters you use carry external shunts or bobbins, you know what the numbers and divisions on the meter face represent in a particular situation. That's also the thing for the 2 amperes, and then somehow it's 0.1, 1.085 and 0.015. There has to be the proper number on it. You should refer to figure 5. We're over time. I can't find figure 5, it must be somewhere over it. Which shows an Ohm's law circuit, and note the way in which the 2 meters are used in the circuit. I see the voltmeter around the resistance, and the ammeter is next to it, and then there is the thing, and then there's more things, and then there's something else. This first chapter has been concerned with helping you to understand the basic problems involved in setting up simple circuits to make electrical measurements. We can now consider the relationship between chemical energy and electrical energy. Well, we got a basic understanding of things. We don't completely understand them all. There's no watering, but basics, and a few things that we actually understood. That means we will continue the next part with electrical engineering. If you were here for electrical engineering, you can go directly to the next part of electrical engineering. If you stay here and participate in the standing yoga, then it's better the owners. Moving the feet same together, you're breathing and lifting the arms up. Throw the arms down. In and up. Out and down. In and up. Out to the side. In and up. Out to the other side. In and up. Make an inch space between the feet and up to the side. In and up. Breathe out and sink down. In and up. Out to the other side. In and up. Out and sink down. In and up. Out, lean onto the knees. Breathing in. And out, make a head of the back. Again in. And out the belly of the back. Again in. And out the head of the back. Again in. Out of the belly. Again in. And out come the round back up. And make at the top of the backward shoulder. Breathe in at the onset. Breathe out on the side. Breathe in up. Out the arms over the sides down. Breathe in, come halfway up. High up and out. Up. Breathe in, reach high. Breathe out on the side. In and up. Out the arms over the sides down. Breathe in, come halfway up. Come high up. And out and come up. Breathe in, come up on the tiptoes. And breathe out and sink down. Breathe in, come up again. And out, bring the hands on the sides down. Breathe in the right leg. Breathe out, stretch the left leg. Breathe in, change. And out, stretch the right leg. In and change. Out, stretch the left leg. In and change. Out, stretch the right leg. In into the middle, and out just down. Breathe in at the right hand up. Breathe out with the left and look over the right shoulder to the right hand. Inhale down, out and down. Breathe in with the left hand up. Breathe out with the right knee, look over the left shoulder to the left hand. In and hand down, out and down. Make a hand of space between the feet. Shift the weight to the heels, breathe in and down. In and down. Out and up. Take hold of the elbows and gently rock from side to side. Hands again down, feet together. Breathe in, come halfway up with a straight back into monkey half lift. Out and down. In, halfway up, straight back. Out and down. And breathe in, come up. And hands again down. Have a leg standing around shoulders wide apart, hand to turn the fingers behind the back and over to one side, tall up, shoulders back, breathe in. And out, head over to one side, chin down to the clavicle, pull the arm and the shoulder down. If you lift the gaze, turn the head over to the other side, hands over to the other side, tall up, shoulders back, breathe in. And out, chin down to the clavicle, pull the arm and the shoulder down. If you lift the gaze and turn the head back into the middle. Feet together. Breathe in, lift the arms up. No. One arm behind the back. And lift one arm up, breathe in. And out, bring the head over. Don't pull at the head. Breathe in. And out, hand down. Our hand behind the back, breathe in, the arm up. And out, bring the head over. Don't pull at the head. Again in. And out the hand down, the head back. Now breathe in, the arms up. Over cross the arms and the 20 fingers, breathe in, reach high. Breathe out, reach in front of the back. Breathe in, the arms up. Over cross and intertwine the other way around, breathe in, reach high. Breathe out, reach in front of the back. Lift and lift the arms up. And out, lean back with the long arms. In and up. Out, lean back. In and up. Out the arms down. Lift and lift the arms up. Bring the hands to touch and lower the hands down to heart center. That was a Zen Yoga. I thank you very much and till next time.